another problem. This is exactly like very much similar to the validation of binary search tree. If you haven't watched that video, please watch that first. Validation of binary search tree. This is yet again the second question and yet again question, different question for a tree. It's a tree base. Again, we'll do on recursion. So what's the questions telling? Like given a root of binary tree, it's a binary tree, right? It's not a binary search tree. Don't confuse. Binary search tree holds the property of like left would be the less than the root, right would be greater than true. Is just a binary tree. Check whether it's a mirror of itself, that is symmetric around its center. So this left part should be the mirror image of the right part. So if you see like 2 and 2 is matching, 3 and this leftmost and rightmost is same, and this 4 and 4 is same. So this is the mirror image of itself. So that is symmetry. So we are returning true. In this case, 1 is fine, 2 and 2 is fine, but if you see like 3 is the right to the left, and here the 3 is right to the right. So it's not a mirror image of itself, each other. So it's not symmetry, right? So we are returning false. So yeah, we need to return just true or false. The approach would be very much similar to the previous question of validation of binary search tree. We'll just take the root and compare the root left and right on that level, and then if that not holds true, we'll just simply return false. If that is true, then we'll go deeper to the deeper level, like the child of this trees, right? So similarly, what we'll do, we'll write a helper function here. So first, what we can do is just a basic simple check we can apply here. If root is null, then it's a symmetry, right? So if we are at the leaf node, it's a symmetry. It's a mirror image of itself, right? So then in that case, we just need to return true. That's the basic case. And then we'll call a helper function. We'll do it later. So first we'll write a helper function. So obviously it will return a boolean. Okay, so what this will take, it will like we'll pass the left tree and right tree to this helper function, right? So we'll just write like tree node left comma tree node. Right. These are just the two parameters. Do two parameters. Now what we'll do? We'll just check if both of them is null, right? If the left is null and right is null, means we are standing it here, right, at the leaf node. Then it's symmetry, right? So first case, if left is null and right is also null, then it's a symmetry. So return true. Now the second case, suppose if any one of them is not null. So suppose this case, right? In this case, or you can just check like if there is a leaf here, but there is no leaf here, right? So that is not a symmetry. Or vice versa, if there is a leaf here, but there is no leaf here, right? So it's not a symmetry. So our second case would be else um, left is null or right is null. Then we need to return. If there is a case in which one child is having the value and the other is not, either left or right, then we should return false. That level is not symmetrical. And then the value we need to check, because this is the value, right? So the value should be same. So either if there is a node here and there is a node here, right? Only node won't make it symmetry. The value also should be equal. The 3 and 3 should be equal, 4 and 4 should be equal. So now the third case, what we'll check, like here, if left dot value is not equals to right dot value, then obviously return. If that is the case, we'll return the false. Now what we'll do, we'll just call this is symmetry, like this helper function, right? This is the helper function. We'll call this two times, like how two times? We'll just call it for this left subtree and then call it for this right subtree. So what we'll do, another case, if helper, first we'll pass the left and right. So we'll pass left to the left, comma, right to the right. If this helper function is returning false, right, then we just need to return false. And similarly, we'll call the helper function on the reverse case. So if this, then what we need to call, like we'll pass the right one. So left, right, comma. If that is returning false, then we need to return. So what actually we did here, first we check the current node and then we call the function recursively. And first, like if we are standing at this node, right, we call the symmetry to we'll call the symmetry function. First we pass 3 and 4 and then we pass 4 and 3. Similarly to if we are standing at 1, so first we call 2 and 2 like this and then we call this 2 and this 2. So both should be symmetrical. Okay, so I think that should be the enough. That is the only case that I can see. And if it is here, right, and then all other conditions are satisfying, then we at the last we just need to write down. Means this symmetry, this current level is symmetry, right? And here we'll call the helper with the root nodes. So the helper will be called by root. The Okay, so this should be enough, and we need to return the result of this. Let's check this. Okay, so we have not value, it's a value. So line number 26, it's a value, it's a value. Okay. Yeah, so it's finished. This case is filed. Let's test for another. So it's accepted. Let me just check whether all the cases are passed or not. All test cases passed. Thanks.